Covalent bonds are an excellent opportunity for one of my favorite wisecracks. Like most bonding, it's a balancing act between attraction and repulsion. It's true love. That's the kind of thing we're talking about with covalent bonds. It's also the most common type of bonding. So I guess that they're fairly romantic down at the microscale. Now, atoms with covalent bonding can also be an ion. I want to remind you of that. We can have our polyatomic ions. The inside of that polyatomic ion, I'll just draw one of them really quickly. And no, you wouldn't know this one yet, but it's coming soon. This is the sulfate ion. It's one of the ones that we do have to memorize, but you won't be able to draw the structure of it for some time. We're going to have a charge over on this side and a charge over on this side, but this is a covalent bond, this one is, that one, and that one. These are all covalent bonds that I just erased. I just wanted to make sure that you saw where I was pointing. So remember, you're going to have covalent bonds on the inside of any polyatomic ion. Now, here's an example of one of those. The carbonate ion is going to have 3 different bonding areas, and it's going to be a covalent molecule that is also an ion. It's going to be a -2 ion. Now, it's going to get ionically bonded to calcium ions. So this is going to be ionic. Right, I can write today. And this is going to be an ion with covalent inside. This isn't a distinction I'm asking you to make all the time. It's one that I want you to get, though. That's why I'm taking a moment to have you spot that. Now let's go through the process that happens when 2 atoms come near each other. Suppose you have something and it's not yet to its octet, or duet if it's hydrogen. We'll have our protons in the center, we'll have our electrons zipping around, and it's not yet looking isoelectronic with a noble gas. It's not happy yet. So it bumps into one that it can actually share with. What's going to happen? Well, this electron is starting to get attracted to that proton, right? It's starting to head that direction. It's occasionally zipping around over there now. As they get closer and closer, the covalent bond forms. We're showing the electrons sitting still for a brief split instant, but remember, they're not sitting still at all, and they're not in just one place either. They're this big blur in space because of a few different effects. So the electron could be in this region right here, right in that instant. There's going to be some space that the electron's in over here. I'm just saying it's smeared out. We know that the shapes don't look like this for orbitals, but the orbital shows us where we can find the electron. Separate from that, the electron is smeared out in space, though of course it'd be a little more smooth than that. But either way, just remember it's kind of distributed out. And eventually you're going to get to the point where you have the balancing act between attraction, black arrows, and repulsion, the red arrows. That's what's going on inside of covalent bonds.